Hello everyone, welcome to our channel Bottom Line Education. Today we are in the MCQ series of class 10 Science and Technology. The unit we are covering today is classification of elements from chemistry. So let's get started. First question. According to Mendel's periodic law, the physical and chemical properties of the elements are periodic function of which property? There are two periodic laws. First we have the Mendel's periodic law, where the physical and chemical properties of the elements are the periodic function of their atomic weights, or sometimes we may also call this as atomic mass. And we have the next one, which we call as the modern periodic table, governed by the modern periodic law, which states that physical and chemical properties of the elements are the periodic function of their atomic numbers. So yes, here we are asked about Mendel's periodic law. So it is based on of increasing order of atomic weight. So our correct option is option number A. Which scientists proposed the modern periodic law, stating that properties of elements are a periodic function of their atomic number? So, and we know there are basically two periodic tables that we have studied and which are governed by two periodic laws. The first one, Mendel's, by Mendel's periodic law, and then we have the modern one, and it was actually given by Henry Moseley. So the scientist who proposed the modern periodic law was Henry Moseley. So why did Mendeleev leave gaps in the periodic table? The reason is very obvious and simple. During the time of Mendeleev, not lots of elements were discovered. Now because of that, when he arranged the elements on the basis of atomic weights, wherever there were huge gaps, he actually leave those for the elements which were undiscovered at that time or which he thought would be discovered in the future. So the obvious reason is not for separating them, not for isotopes, and not for the noble gases aligned. It is to accommodate. Accommodate basically means to adjust the undiscovered elements. Correct option number D. What is the maximum number of electrons that can be accommodated? Accommodated basically means adjusted in the d subcell. Okay, subcells are basically also called as orbital or subcell, same thing. And what is the maximum number of electrons that they can adjust? We must learn that there are four orbitals, four types of orbitals: s orbital, p orbital, d orbital, and the f orbital. And s can accommodate the least number of electrons, only 2, and the trick here is basically to add +4 in every orbital as we move in the lower order. So p can adjust 2 plus 4, 6 electron, d 6 plus 4 again 10 electrons, and f 10 plus 4 again, so we have the 14 electrons. Now in our question, in d subcell, the maximum number of electrons that can adjust is obviously 10. Correct option number D. How does the atomic radius change when moving from left to right across a period in the modern periodic table? Okay, let us suppose a period starting from atomic number 11. Let's say sodium, then we have magnesium, then we have aluminium, and so on. Now sodium has electronic configuration of 281, magnesium 282, aluminium 283, and likewise. Now we might think at first that there are only three cells and 3 cells, so they all belong to the same period, that is period number 3. Now we might think that the atomic size will be obviously the same, or it will keep on increasing from moving from left towards the right. However, that is not the case. The reason is little deeper. Let's have a look at the reason. In sodium, the number of protons is actually 11 because of atomic number being 11. In magnesium, the protons increase and become 12. In aluminium, the protons increase and become 13, and so on. When the number of proton increases, the electrostatic force of attraction also increases. So when the number of proton increases, the electrostatic force to the electron on the outermost cell also increases. Now because of that, the force is stronger, so the atomic size, if it is of that much, in the case of magnesium, it will decrease a bit, and in the case of aluminium, even it will decrease little more. If sodium is having an atomic size of that, then magnesium will have slightly smaller, and aluminium will have even smaller, and so on and so forth. Why? Because as the number of proton increases, the electrostatic force inside also increases. So this inward force, this inward pull is actually increasing, and because of that, the atomic size or the atomic radius actually decreases. So from left to right, we can see that the atomic size, or we can say the atomic radius, actually decreases. So it decreases as we move from left to right. So the correct option is not increases and decreases. That's absolutely wrong. It decreases gradually. Correct option number B. Next, in the modern periodic table, why is helium placed in the p block despite having only the s electrons. Now if you look in the periodic table in our last group, that is group 8a, we can see at the end that the elements are arranged like this: helium, neon, argon, and so on. Now the reason why they are kept together is that these all actually belong to a category of inert or the noble gases. Now they are very similar in properties, and for that reason they are actually placed on the same group 8a, though helium is a s block element. So the obvious reason is because of being the inert gas or the noble gas. So it has two valence electron like the group 2a. Obviously that's not the reason. It has completely filled valence shell, making it an inert gas. This is the correct option, number B. Next, which principle states that electrons are distributed in atoms such that they occupy shells in the order of their increasing energy levels or increasing energy. Now obviously we have read that in grade 9, I suppose. So that is basically called as Aufbau's principle. Now Aufbau is a German word and its meaning is actually building up or making up. So when we arrange the electron in orbitals like this, like for example we put in 1s, then we have in 2s, then we have in 2p. So the energy level of each of these orbital actually increases. So we can say that the correct answer is option number C, of Bau's principle. Next, which of the following is a merit of Mendel's periodic table? Here merit basically means advantage or benefit. Now what does Mendel's periodic table advantage lie on? Let's look at that. He corrected the doubtful atomic weight of some of the elements. So yes, he is actually credited for that. A clear position for hydrogen was not given. There was no placement for isotopes. He could not explain that. And obviously lanthanides and actinides were not separated. This all were done by the modern periodic table. So what we can say, the best option here looks out to be option number A in correcting the doubtful atomic weights, because Mendeleev actually arranged the elements on the basis of increasing atomic weights or atomic mass. What happens to the metallic character of the elements as you move from top to bottom in a group? Okay, let us consider group 1A for this case, and I'm actually ignoring hydrogen because it's not a metal. So let's consider three different elements. So in group 1A, let's consider lithium, sodium, and potassium. Now let us look at the electronic configuration. Lithium has a smaller atomic size, sodium has a bit bigger, and potassium even bigger. Now the reason for that is obvious. Lithium has only 2 cells, sodium has 3 cells, and potassium actually had 4 cells present. So as the number of cell is more, so size is also more, the atomic size is also bigger. Now if we look at the valence electron of all of them, each of them has got only one valence electron. So I'm just going to draw one valence electron of each. Now in all the cases, though they have got one valence electron. In the case of lithium, the distance from nucleus to the electron is less, and in the case of sodium it is a bit more, and in the case of potassium it's even increasing. So what we can say is that as we move down, the atomic size or the atomic radius actually kind of increases. Now when the atomic radius increases, what happens is that they have a tendency to lose the electron. So lithium can lose not so easily, sodium can lose. Now compared to all the three metals, the potassium can lose the electrons. Now if we compare lithium and sodium only, the sodium is becoming the winner, obviously a clear one. Now if we have lithium, sodium and potassium all together, then again potassium is the winner. Why? Because as we go down, the atomic radius increases and the reactivity, okay, the reactivity also basically increases. It becomes easier to lose the electron which is loosely bound, and because of that what we can say, the reactivity actually increases as we go from top to bottom. So it increases as we go from top to bottom. Correct option is number A. Next, the amount of energy required to remove an outermost loosely bound electron of an isolated gaseous atom is called dash. Now we have to read that. This is basically to remove the outermost loosely bound electron, basically means the result in the formation of the ions, and that energy is basically called as ionization energy. Energy required to remove outermost loosely bound electron of isolated gaseous atom. Ionization energy. Which group of elements in the modern periodic table is known as the halogens? Okay, this is actually a very commonly asked question. Halo here means salt, and Zern here means forming. So these are basically the elements which are found very commonly in the case of salts. The halogens actually make a list of elements like fluorine, chlorine, bromine, iodine and so on, and they all belong to group 7A. So the group of elements belonging to halogens is group 7A, or it's also called as group 17. Now group 7A, or it is written group 17, basically means the same. So please watch out for the option. Correct option group 17, option number B. How many elements are present in the second and third period of the modern periodic table? Okay, we should know this. In the first period, in the second and third period, in the fourth and fifth period, and sixth and the seventh period. So the trick here is to use the 2n square law. Okay, so for the first one, if we use 2n square, it actually becomes 2 times 1 square, so that becomes 2. So 2 elements are present. Now let's use the same for second one. So 2 times 2 square becomes 8. So we have the second as well as the third. We have 8 elements and again 8 elements. They have a total of 16. Now we go to the fourth and the fifth period. Again we use the same 2n square law. You'll get 2 into 3 square. So here n equals to 3. So we get 18 in fourth and again 18 in fifth as well. And finally in sixth and the seventh, that is for fourth, we basically use 2n square, then we get 2 into 4 square, which will be basically getting 32 and again 32. So this is the one of the tricks to remember. This is the trick for remembering which period has how many elements present. Now here we are only looking for the second and third period, and our obvious answer is 8 and 8 each. So the correct option is number B, 8 electrons. Next, what is the correct subcell electronic configuration for magnesium? Subcell means in terms of SPTF. So for magnesium, atomic number, the atomic number of magnesium, it comes after sodium, it is actually 12. If we place them, it becomes 1s2, then we have 2s2, 2p6. So that becomes 6 plus 2, 8 plus 2, 10. We want 2 more. So again, we'll go with 1s2, 2s2, 2p6, 3s2. So now let's look for the correct option. 1s2, 2s2, 2p6, 3p2. Okay, that's actually wrong. It's very easy to get confused. Let's look for second one. 1s2, 2s2, 2p6, 3s2. Yes, B is correct. So we have to watch out for very small errors. So yes, you can easily confuse with option number A. Which of the following is true regarding the valence of elements in a group? Okay, let's look at this group again. Let's consider sodium, then magnesium, then aluminium. Let's go up to silicon, phosphorus, sulfur, chlorine, argon. Okay, let's go up to here. Now sodium actually loses 1 electron and becomes octet, so its valence is 1. Magnesium will lose 2 and it will become octet again, so valence is 2. Aluminium will lose 3, valence is 3, and so on. Now when we go to sulfur, sulfur actually does not lose 6, but it actually gains 2. It gains 2 more electrons, so the valence is actually 2. In the case of chlorine, it needs 1 more electron to become stable, so it will gain 1 more electron, so it will become actually 1. And argon, group 0 element, valence is 0 because already stable. So what we can see from here is that actually the valency first increases and then it actually decreases. So 1, 2, 3, 4, like that up to 2, 1 and 0 finally. So it increases and then decreases. So it first increases and then decreases. Correct option number B. Where are the metalloids located in the modern periodic table? Okay, actually in our modern periodic table, the metals are on the left side of the periodic table. Similarly, our non-metals are placed on the right side of the periodic table. Now not exactly in the middle, but in the borderline is where the metalloids lie, and no wonder their properties are actually, some properties are like that of metals and some are of non-metals. So they are not on the extreme left, that's of metals, not on the extreme right, that is of non-metal, and separate block at the bottom. The separate block is actually of lanthanides and actinides, and which are also metal. So this is actually also wrong. So they are placed between metal and non-metal. Correct option number D. The tendency of an atom to attract the shared pair of electrons towards itself in a chemical bond is known as what? Okay, so tendency to attract. So when an atom basically attracts the electron, that's on the outside, if it is attracting it, now the negative character of the atom actually increases. So since the electrons carry negative charge and the tendency to attract also increases the negative charge in them, we call the tendency actually as electronegativity. So the correct option is number C, electronegativity. Next, how does the chemical reactivity of non-metals change when moving down a group? Okay, for this let's consider one group as an example. Let's take group 7A. So we have chlorine, chlorine, bromine, and so on. So fluorine has got the smallest atomic size, chlorine little bigger, and as we go down the size actually increases. The tendency of all of this atom is to add one more so that they can become stable, one more so that they can have 8 electrons in the valence shell. So here also one more. Now to attract the electron, right, let's have a look at the atomic radius. Now for fluorine it's very easy to attract because it has actually got the least atomic radius. Now chlorine little further to pull by the nucleus, and in the bromine even further. So what we can see is that the atomic radius or the atomic size actually increases as we go below. Now since it is having a larger atomic size, it's difficult for the nucleus to pull the electron that's on the outside for gaining. So as it is more difficult to pull for fluorine, it is very easy to pull. For chlorine, okay, I'll just keep it easy. For bromine, not so easy, right? It's not so easy for bromine because the atomic size is increasing, and because of that the chemical reactivity actually, what we can say, it decreases. As we go down, the chemical reactivity becomes less and less, or we can also say that the non-metallic character also decreases. So here it increases, it's actually wrong. So we are moving down, it must decrease. So the correct option for number 17 is it decreases. Why is hydrogen placed in group 1 of the periodic table? So group 1 basically means group 1A of our modern periodic table. There are many reasons for keeping it. Okay, one reason is hydrogen electronic configuration of 1, that is 1s1. So since it is an s block element, it's kept over there. And another reason is actually it has only one electron in the valence shell, so just one valence electron. So this is also one of the reasons for keeping it over there. Hydrogen actually has a tendency to actually form positive ions just like alkali metals. So these are the probable reasons why it has been kept in group 1A, right? So now let's look for the answer. It is an alkali metal. No, it's not an alkali metal, but it is able to form positive ions just like alkali metal, so that's wrong. It exists as diatomic gas. Hydrogen is obviously a diatomic gas, but it is not placed in group 1A because of that. Oxygen is also a diatomic gas. Next, it has the highest electronegativity, which is obviously wrong, and it has one electron in the outermost shell. So the convincing reason shown out of 3 that we discussed is one electron in the outermost shell. So correct option must be option number 18 is D, one electron in the valence or the outermost shell. Next question, what was the major demerit of Mendel's periodic table regarding the arrangement of elements? So demerit here basically means disadvantage, right, or the bad part about the Mendel's periodic table. So he included noble gases in the wrong group. Okay, so what we can say is that is not a probable reason. Okay, we have to watch out for the other option. He placed elements with the lower atomic weights after those with the higher weights. Yes, there was an issue like that, so let's keep it for now. He grouped metals and non-metals together incorrectly. That was also one of the probable one. He failed to identify the existence of periods. So no, he actually separated groups and periods. Now here the most convincing answer is he placed the elements with lower atomic weights after and then with the higher atomic weights first. So he placed the higher ones first and the lower one later in some of the cases. So the correct option is option number 19, B, lower and higher issue. Which block of elements in the modern periodic table contains the inner transition elements? Okay, this is actually kind of little interesting question. So let's look at the modern periodic table first. So this is actually an outline of our modern periodic table, just a gimmick. Now, so just like the cross, S, P, D and the F. Remember that S, P, D and the F. That's how our blocks are separated. So S here, P here, D here and the F below. Now among them, the D block element are also called as transition elements, and F block are also called as the inner transition elements or transition metals, right? Now the correct option here is actually F block, which are the inner transition elements. Now if the question was just transition elements, the answer would be D block elements. So please do not get confused of transition elements and the inner transition elements. Now in this case, inner transition elements, option number C, F block. What happens to the electronegativity of the elements when moving from top to bottom in a group? Okay, now electronegativity means ability to attract the electrons. Now let's have a look at that. Let's consider this group. Order lithium's atomic size is smaller, sodium is bigger, and potassium is even bigger. Why? Because the number of cells are in the increasing order. Let's see 2, 3, 4 cells. So because of that. Okay. Now let's have a look at this. So which one has the better ability to pull the electrons? If you look over here, the ability to pull the electrons is maximum of lithium. So lithium can pull the electron very easily. Sodium not so easily. And in the case of potassium, it is kind of, let's say, difficult. Why? I can say the energy actually to pull, supplied by the atom is kind of decreasing. Okay, now because of that, what we can say, the correct option is it does not remain constant. It first increases and decreases. Obviously not. It actually, when we move from top to bottom, it actually decreases. Correct option number D. Next, in the modern periodic table, which elements are classified as inert gases? Okay, it's very easy. The elements belonging to group 0, or we can also call them as group 8A, or sometimes they are also called as elements belonging to group number 18. So we call them as the inert gas, and another name for them is also the noble gases. So, and all of them actually have, except the helium. Helium has 2 valence electron, and except that all have 8 valence electrons on the outermost cell. So let's look out for the answer. Elements in group 17 is actually wrong. They are basically halogens. Group 18 with a complete octet or duplet. Yes, that seems convincing. D block do not react with oxygen. No. Group 1 that are gases also no. So the correct option is elements in group 18 with complete either octet like neon, argon, or duplet like the helium. So correct option number B. Which of the following describes the change in valency across the third period from sodium to argon? So let's have a list of the elements: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, okay, then chlorine, then argon. Now sodium has electronic configuration of 281, magnesium 282, aluminium similarly 283, goes on, we reach 286, we reach 287, and finally we reach 288. Now if you look properly, sodium will actually lose this 1 electron, so its valency is 1. Magnesium will lose these 2 electrons, so its valency is 2. Aluminium will lose these 3, so its valency is 3. As we go on, in the case of sulfur now, it will not lose 6, but it will gain 2 more electrons, so the valency is 2. Chlorine will gain 1 more electron to have 288, so its valency is 1. And argon, obviously it does not want to take part, so its valency is 0. Now what we can see, so first the valency is actually on the increasing side, and after that again it is gradually decreasing. So let's look for the best option. It is constant at 1, wrong. Decreases from 7 to 1, wrong. Increases from 1 to 7 and then becomes 8, wrong. Increases from 1 to 4 and then decreases to 0. Correct option number D. Which series of elements belong to actinides? Okay, now there are 2 groups of elements which belong in block F, that is lanthanides and actinides. So it actually consists of 18 elements, and some of them are thorium and lawrencium. So the correct option is option number B. What is the primary reason that alkali metals become more reactive as you move down in group 1? Okay, let's consider group 1A. Okay, lithium has a smaller atomic size, sodium little bigger, potassium even bigger because the number of cells increases. Now why they become more reactive as we move down? Now the tendency, let's look at the tendency. Lithium has a tendency to lose this 1 electron to become stable. Sodium also loses 1, potassium also loses 1. Now the question is, who can lose the electron very easily? Now lithium actually has got a very small atomic size, so the electrostatic force of attraction is very strong. So lithium cannot lose very easily. Sodium, it can lose quite comfortably, and potassium, we can see the distance, of the valence electron from the nucleus, which is actually very big. So since in this case we have the atomic radius, is increasing, and because of that the tendency to lose the electron is also increasing. So since bigger atom, it's always easy to lose. A small atom, it's always easy to pull or gain the electron. Now here our most convincing answer is, because of the increasing the atomic size. Transition, wrong. Atomic size increases, making it easier to lose an electron. Yes. More valence electron, no. Electronegativity, no. So the correct option here is option number B. Next, How many groups and periods are there in the modern periodic table? Okay, we should remember this. In our modern periodic table, the number of periods, okay, is actually 7, and the number of groups is in total 18 groups. So period means 1, 2, 3, 4, 5, 6, 7. We have total of 7 rows, and groups means actually column 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so we have a total number of horizontal rows 7, and we have a total number of vertical columns 18. So let's look out for the option very carefully. 7 period 18 group, 7 group 18 period. It's actually wrong and very easy to confuse. 8 groups 7 periods, so it's saying groups are 18, but we have 8 groups, so it's wrong. 18 groups and 7 period, okay. 7 period 18 group sounds okay, and 18 group, that is actually wrong. No, 18 groups and 18 period, okay. 18 period is wrong, so yes, correct option is number C. So I want you to very carefully look at the options. See, they are very confusing. Next, in the modern periodic table, the atomic radius of elements generally decreases from left to right. What's the explanation for this? If we consider the case of sodium, magnesium, aluminum, and so on, okay, what happens in sodium? The number of proton is less, magnesium more, aluminum more, so number of electrons increases from left to right, number of protons also increases. Now if sodium is having that size, now in magnesium the electrostatic force of attraction will be stronger because more proton will be there, one more proton, so the size will be little small in aluminum, and it will be even smaller. So this is how the atomic size goes on in a period. Now let's look at that. What is the reason? The addition of new cells increase the distance. That's wrong. The number of valence electrons increases, causing greater interstatic repulsion. Okay, repulsion is not the case. It does not expand from left to right. No. The screening effect of inner electrons significantly increases, pushing the outer cell away. That's also wrong. So it's asking why it decreases. So as you can see, it is talking about increasing. It's talking about increasing and increasing. So increased nuclear charge pulls the electrons of same cell more strongly towards the nucleus. Correct option is number D. So thank you all for watching and learning from this MCQ series. We will be back soon with another video. Till then, thank you so much. Bye bye and prepare well.